In the previous video, we have defined the fundamental node class that we can use for representing each and every node that we have inside a single linked list class, right? In this video, let's try to define the similar class that we will use for representing the single linked list as well as for adding all the functionalities that we need to have inside any linked list class. So when I explained you the terminologies that we have inside the single linked list class, right? So I clearly mentioned the very first node we have inside the single linked list class, we will call it as a head node, and the very last node we will call it as a tail node of a linked list, right? So in the linked list that we are going to implement, specifically the single linked list that we are going to implement, it is very important that we have the access to the head node. Once we have the access to the head node, right, this is of type node that we have defined earlier, right? So in this node class we will have the value and we will also have the reference to the next node. So using that next node, from the node 10 we will be able to go to the node code. Similarly, from the node code we will be able to go to the node true. Similarly, likewise, we will be able to reach the very last node, that is false. Once we reach the last node false, at the last node the next pointer that we are maintaining is basically empty, using which we will be able to say we have reached the end of the singly linked list. So here our aim in the process of representing the singly linked list, right, we have to have the access to the head node for sure. So our primary criteria that we should have inside the class that we are going to define will be head pointer should always be there, okay, and it should always point to the first node we have inside the singly linked list. And the second thing is, as part of implementing some of the functionalities such as push functionality, where we try to add the new value at the end of the singly linked list. At that point of time, if we have the access to the tail node, right, we will be able to add that new node very easily. If we don't have access to the tail node, right, first our implementation would be requiring you to go to the very last node. After going to that last node, we will be able to add the new node there. That's why, to reduce that functionality, and what exactly we will do is we will maintain one more value called tail inside the single linked list representation. So just you have to remember that the tail node reference that we are maintaining inside the single linked list, we are trying to use it in such a way that it will reduce the complexities involved in some of the operations that we implement later on. That is something that you have to keep it in your mind. And inside the tail variable that we are going to define, we will always keep the reference of the last node in that variable. Besides these two variables, right, obviously head is the first node and tail is the last node. So besides this, some of the common functionalities that we implement are insert, remove, and get and set are some of the functionalities that we will have inside the single linked list, right? While implementing these functionalities, what exactly we will do is we will try to take the index from the user. So the index, based on the value that user is passing, we will try to perform that specific operation. At this point of time, you don't have to worry, but you just have to remember that just like the operations that we have in the array, where we take the index and we try to update or insert a new value at those indexes, we will try to perform the similar operations in the case of single linked list as well. So to make sure that user, whatever the value that we are taking from the user, if it is falling in the valid range or not, we will also try to maintain the length of the singly linked list as well. So just like how tail that we are maintaining, that is making the process of implementing some functionality easier, the process of keeping track of length also will definitely help us in implementing some of the functionalities very simply. If we don't have the access to the length, right, first our job would be to our job would require us to start at the head node and traverse till the tail node, and then find the length of the linked list and use that length for implementing the functionalities. This will basically increase the time complexity. So to make sure that we are bringing the time complexity down, we will also make sure we are maintaining the length of the singly linked list as well inside our implementation. So these three variables we are maintaining inside the class that we are going to define for representing the singly linked list class. So for class representation, what exactly we will do is we will define a class called singly linked list. Okay, inside this linked list, what we will do, we will define three variables. One will be head. Remember that this head should always point the first node of the singly linked list, and each and every node is of type node that we have already defined previously, right? So we have to make sure that the node type objects are getting assigned to this. Okay, similarly after head we will also maintain the tail node. Similarly in the tail node we will always make sure whatever the operation that we are trying to perform, we will make sure that always the last node reference is available inside the tail. Similarly, this just like how we are maintaining in the head node, the object of the tail node will also be exactly of type node that we have defined. And along with this we will define one variable which will basically contain integer values, since length is an integer, right? In this length we will maintain the length of the singly linked list. Once we define that empty singly linked list class, right, what exactly we will do is we will try to add the no argument constructor. So inside that constructor, at the time of object creation, obviously we don't have any values inside the singly linked list, right? Basically it is empty. To represent that empty state, what exactly we will do is inside the no argument constructor, whatever the head variable that we have defined, right, head variable we will assign it with null. Similarly, we at the time of object creation, obviously there are no values inside the singly linked list, right? Similarly, the tail node also we will assign it with null. And since the singly linked list is empty, obviously length of the singly linked list will be 0. So we will make sure that inside the no argument constructor that we are defining, we will make sure that to represent the empty state of the singly linked list, we will assign the values like this. Okay, so that is what theoretical representation of a singly linked list class. Now let's go ahead and let's write it programmatically. So for that, anyway, inside the singly linked list class, whatever I have created, right, here for implementing the singly linked list, what I will do is I will simply create one file called singly linked list.cpp. Okay, let this name be caps like this. Okay, now here basically let's just import the basic boilerplate code that we would be needing. And if you remember the structure of the singly linked list that we have discussed, right, as part of the singly linked list, what all values we will be keeping track of? We will be keeping track of the very first node that we have in the singly linked list, which is also known as the head node. Along with that, we also will keep track of the very last node, which is also known as the tail node of the singly linked list. Along with these two nodes, we will also keep track of the length of the linked list, which is basically helpful while implementing some number of features that we have as part of the curriculum on the singly linked list. So these three values are something that we will be keeping track of while implementing the singly linked list. Out of those three, first node and last node, which is nothing but head and tail, are nothing but nodes, right? That node is something that we have already set up. So first we need to import that node here. So here what you can do is you can simply do include, what you can do, the file for node class that we have written is node.h, right? And it is inside the same singly linked list folder itself. So you can simply do node.h. Automatically it will bring that specific node class into this particular implementation. Okay, now for implementing the singly linked list, what we will do is we will write one class called singly linked list. Okay, here what we will do, we basically need access of three variables, right? One is head node, tail node, length, and the type of head is nothing but the node that we have defined here. So what we will do here is we will basically define node. And one more thing that you need to remember here is, just like how we have defined the template for node class for defining the type of the value that is being stored as part of that specific node, here also we will be defining the similar structure, so that when we initialize the singly linked list, we are telling that singly linked list what type of values we are going to store as part of that specific singly linked list object. Let's just say if I want to create a singly linked list to store only integer values, there we will mention singly linked list which stores of type integer. Similarly, if you want to create a singly linked list which will store strings, just like how we have defined the type while creating the object in the node class, similarly we will mention the type such that that specific singly linked list will store that specific type of values only. So ultimately what we are trying to do is we are trying to build the generic singly linked list here. So first here, let's just define the template, okay, and let's just say the type is T only, like how we have defined previously. Now internally, whatever the node that we are defining, right, if the singly linked list is storing the values of type integer, ultimately the node will also store the integer values only. So here we just need to pass the same type, and we are storing the reference of the head node. So let's just name the variable as head. Similarly, we need to keep track of the tail node also, right? So let's just define one more variable node, and the tail node will also contain the similar type of values, because when we initialize the singly linked list object, we are saying that it will contain integer values. That means all the values that we have inside that specific singly linked list is of type integer. For example, if we say singly linked list of type boolean, all the values that we have in the singly linked list are of type boolean. So ultimately the type of values we will have inside the tail node will also be of node type T only. So I have created one more variable for storing the reference of the tail node. Along with this, I have also mentioned that we will be storing the length of the linked list as well, right? Length is nothing but number. So what we will do is we will define one variable called length. Okay, now when we initialize the object, at that point of time, obviously there will be no values inside that singly linked list, right? That means head will be empty and the tail will be empty and length will be 0. So let's just initialize that in the constructor of this singly linked list. So let me just initialize a no argument constructor here. In this, let's just assign head to null, and similarly tail also let's just assign it to null, and length let's just assign it to 0. Okay, now we have basically defined a empty singly linked list. In the case of empty singly linked list, head and tail will be null and length will be 0. Just remember these values when the singly linked list is empty, because these values will basically help us in implementing the functionality specific cases that we will be discussing later on. But anyway, at this point of time, when the singly linked list is empty, we have initialized the head node with null value and the tail node with null value and the length with 0. Okay, so that is something that you need to remember here. And one more change that you need to do here is, here whatever the node.h class that we have defined, right, here we have the value of type T, and this T type is basically coming from whatever the value that we are adding here. Type value that we are passing to singly linked list, that itself will go to the node class as well. So that is fine. Here the next node whatever we have, since singly linked list of type integer, the next value from the current node will also contain the same type of value, right? So here one more thing that you can do is you can specify the type as type of the node for the next as like this, what you are seeing on the screen. So this is a small modification that you need to do in the node header file that we have already written in the previous steps. Okay, so that is small change according to the type of the values that we are storing in the singly linked list. Okay, so that is the basic structure of singly linked list, which basically contains no values at all. Now let's just try to initialize the object of this, and let's just try to print head, tail and length to confirm if it is empty or not. So let's just do here, and here let's just initialize an object singly linked list SLL, and let's just do here for printing, right, later on while implementing some other functionalities also, we will be printing the head node and tail node values basically. That's the reason why let's just try to write one function void print head and tail. Okay, this function basically will not take anything because internally we have the access to the tail node, head node and length, right? So we can use that. Now here let's just do if this dot head, if it is equal to null, let's just print out cout null head is null, I mean, or else whatever the appropriate string that you feel, you can add that. Here I'm just going to do endl. If the head is not null, that means that there is a proper head node, so ultimately we will have the value in it, so we can print that. So let me just copy this value. Here what we can do is this dot head dot, this head is of type node, right? In this node again we will have the value, so we can print that. So we can simply do value. Okay, this is the logic for printing the head. Similarly we can copy the same logic for the tail node printing as well. So let's just make this as tail. Here let's just modify, if the tail is null, let's just print tail node. Let's just add node also here just for readability purposes. Here let's just print tail dot value. Okay, now here on the, obviously this function is inside the singly linked list class, right, which we have already initialized. Now all we can do is we can simply, remember here this object initialization is not correct. Why? Because we need to pass the type of the values that will be there inside the singly linked list, right? Because we have defined the template, so we need to pass the type here. Let's just say I want to create a singly linked list which will store all the integer values, so I need to pass the type as what you are seeing on the screen. Now on the object reference I can directly call the print head and tail function directly, so that it will print the head and tail values. Since there are no values at all in the singly linked list, obviously head is null, tail is null. That is what we should be seeing on the console. So if we run it, run code, see head node is null and tail node is null, and that is something that we have printed. One more thing that you can do here is we want to print the length also, right? And you can just modify the head and tail and length. Okay, here just let's not, obviously it is an integer, right? And the default value we have is 0, so we don't have to worry about all these null checks and all for the length. So what we can do is length is, here we can simply do this dot length. Okay, so if I run this, since it is empty, length should be printed as 0 on the console. Okay, yeah, I modified the function name, right? So I need to modify that in the function call as well. So if I run this code now, the output will be C. Head node is null, tail node is null, and the length is 0. Okay, so that basically means that we have successfully initialized a singly linked list to store the integer values. If at all, if we want to create a singly linked list which basically stores all the string values, then what we will do is we will initialize an object like this, and let's just name this object as SLL2. Here we will do the SLL2 the same thing, and again on this SLL2 also we have not added any of the values into the singly linked list, right? Obviously if we print the same thing, it will again print null null and length as 0 again. So that also we can confirm here. See, for first integer singly linked list it is empty, and for string singly linked list also it is empty. As a result we've got null null and 0. So in this way you can initialize any type of singly linked list according to the type of values that you want to store. Okay, so once you define this type, the entire values that we have in the singly linked list will be of same type. Okay, so that is something that we should never forget. Okay, anyway, so that is the setting up of singly linked list class for implementing all the features that we have in the curriculum. Okay, so thanks for watching this one. In the next videos we will get started with the very first operation on singly linked list, that is push operation. Okay, I'll see you there.